Good morning. How are you, my dear students? I miss you all. Today, inshallah, we'll continue explaining our lesson 3 in Unit 1, which is talking about forces and energy. We are explaining in lesson 3, which is energy transfer and collisions. The objective for this period or this video to investigate how energy changes when objects collide. Investigate, that means we have to do activity. We will do, inshallah, a very nice activity. You will learn a lot from it. Let us revise the meaning of our lesson title, which is energy transfer and collisions. Energy, which is the ability to do work. We have two main types of energy, which is potential energy, stored energy, and kinetic energy, which is energy of motion. A transfer means move from one place to another. Collisions, which is when two objects or more hit each other with a force. So collisions mean crash or clash. Today in our activity, we will see what will happen when cars collide. We will use toy cars and we will observe and investigate what will happen when these two cars collide together. Which type of energy transfer from one car to another. We will learn how the speed of cars can affect the movement of the second car. Remember that with me. In the last terms, when we explain speed and energy, we said more speed, that means more kinetic energy. More height, that means the object has more potential energy. For example, if you run very quickly, that means you have more kinetic energy. If you run slowly, that means your kinetic energy is less. Okay, more height, that means there's more potential energy stored. Like if you have two cars, one car stopped at the top of the table and another car at the ground. Which car has the most potential energy? The car which is on the table, because the height is different and it has a high height. So again, more speed related to kinetic energy and height related to potential energy. Again, remember with me, energy can transfer from one object to another. Energy can transfer from one system to another, from one place to another, like how light transfer from one corner to another corner in your room. And energy can transform means change its form from one type to another. Now, please open your book, page 44. In page 44, you have a prediction question. This prediction question asking you what will happen to the stationary car as you increase the speed of the moving car. After building the model, now I will show you how you can build the model and which material you needed to build this model. Think about this. Do you think what will happen to the stationary car, which is the car which is at rest, as you increase the speed? Remember, speed related to kinetic energy, that means more energy. What will happen to the car at rest if this car with the speed collide this car which is at rest? I will explain for you what you have to do to build the model and what you will measure the distance of the car that move it after collide or crash with the moving car. So look with me at this picture. This picture shows you the model which is you have to build it. Look, you need 5 books. Choose any 5 books you have it, math, English, science books. We have to build RAM by using cardboard or paper, thick paper. You need 2 identical cars with same weight and same size. You need tape to put marks and to fix the box with RAM. Also, you need here ruler or meter stick to measure the distance. Look here, we have two cars, one car at the top of the ramp and one car at the bottom, standing here, it's at rest. This car, which is at the top of the ramp, is stored in potential energy, the most potential energy this car have it at this point because of the height. After that, when you leave this or drop this car, the potential energy transforms to another type of energy, which is kinetic energy, because of the motion of the car. So here you can see example, you can observe, you can learn example of energy transformation, how potential energy change into kinetic energy or converted into kinetic energy. Okay, look what happened when you drop the car. Some kinetic energy also can transform into sound, to the sound. And some of kinetic energy change into heat. You can hear it again.
There is friction between the ramp and the toy car's wheels.
Friction.
As more potential energy is changed to kinetic energy, the car will move faster. When the moving car strikes the stationary car, some kinetic energy is transferred to the stationary car, making it move.
Okay, so when the car collides the stationary car, this car which is moving, crash the car at the rest, make it move because some of its kinetic energy transfer from this car to the bottom car. Now you can follow the steps in your book, page 44, to build a model to explore toy car crash. You need 5 books, any 5 books, cardboard, masking tape, 2 toy cars. These 2 toy cars must be same size, they are identical, must be same size and same weight to get accurate data and results. Also you need meter stick, or you can substitute it by using ruler. Okay, now you can watch this video to learn how you can build your model.
You may want students to mark 2 corners to make aligning the books easier. Model how to line the cars up so that they collide when released. Explain to students that they should look down the ramp and line up the top car with the bottom car. Show students how they should use a meter stick to measure the distance the toy car travels when the distance is greater than 100 centimeters. Explain to students that the cars may travel more than 100 centimeters before they come to a stop. Lay out the meter stick. Place the car some distance past the end of the meter stick. Next, explain that students will place a piece of tape on the floor to mark the end of the meter stick. You may want to ask students what measurement the tape would represent. Since we are using a meter stick, the correct answer would be 100 centimeters. Now explain to students to gently slide the meter stick past the tape until the 0 mark on the meter stick aligns with the tape. Next, determine the distance from the tape to the car. In this case, the measurement is 12 centimeters. Show students how to add the 2 distances.
So here, 100 centimeter, which is from the ramp to this mark, and 12 centimeter, that the distance which is car, move it after collide with the moving car.
Together, to get the car's total distance traveled from the end of the ramp. In this case, the car traveled 112 centimeters for this trial.
Okay, so now you know the materials. All these materials, I think you have it in your home. You can do it by yourself. It's easy. First step,
demonstrated earlier.
You have to...
For step 4, students may have difficulty getting their cars to collide consistently. Explain to students that any time the cars don't collide, or the stationary car does not move away from the ramp, then the trial should be redone.
To get accurate
For groups that are
results.
having difficulty with this step, have them use the meter stick as a guide. Students can place the meter stick on the ramp. Place the car on the ramp and position it so that the car rolls alongside of the meter stick.
They must be in
This will help
a line.
direct the car so that it collides more consistently with the stationary car. In step 5, explain to students that they will record their measurements.
You have to record the
in the
data, the measurements using ruler.
In step
And step 7 and 8, you have to
from
remove.
their staff.
Look, in this step, you have to change the height of the ram. At first step, we use 5 blocks. Then you measure the distance that car transferred after collision. Then at each step, we'll repeat the procedure of car's collision, but we will change the height of ram. When we change the height of the ram, that means we change the energy. Then the speed of the car, the moving car, it will change, it will decrease. Then you will note what the difference between the speed when the ram was built by 5 blocks or with 2 or 1 box. What will happen to the car after collision?
How students remove the books from the bottom of the stack.
Now
This way,
3
you don't
box.
have to retape the ram.
Rams become shorter. We will repeat the same steps. We will repeat the same steps. You will put the car here and drop it. Then you will measure again the distance of a new place for the car. You have to fill the table, page 45, and you have to write your observation. Did you hear any sound? If you touch it, there's any thermal energy? Where, in which situation, in which step the car moved more, in which step the car has more speed? Write the results in each trial and your observation. Okay, look at this table, page 45. You have to fill it. Here, your investigation and your observation. You have to write look here, the distance from starting point, stationary car distance from starting point, which is you will measure it by using a ruler. You will repeat each step 3 trials, 3 times. So trial 1, write the distance, trial 2, trial 3, and calculate the average. Observation, what did you see or what did you observe during your activity? What happened to the car? It make noise, there is sound, or it's push the car more distance. Write your observation about each step. You have to repeat it 3 times, 3 steps with different height of ram. First step using 5 blocks, then remove 2 blocks and use 3 blocks. Last trial, use only book and register or record your data. Before that, don't forget to make your prediction about your activity, what will happen to the stationary car, which is at rest, as you increase the speed of the moving car, and compare your prediction with the results. This slide shows you the expected result. The lower ram when you use 1 book, and the slower the speed of the moving car, that means less noise and movement of the stationary car was observed. So again, when you use lower ram, which is 1 book, that means it has less speed, so it's slower. That means the car, which is at rest, has less noise during its moving, and the movement of it, or the distance that this car, stationary car, move it, is less. This you will observe it during your activity. Please do your activity in your home. Take a picture, send it to me, and fill the table, page 45. See you next period in next video.